So kicking off here with the agenda, I can see most of your names through the chat. Some of them I recognize, the others, I think you're kind of telling me who you are and what your interests are. So thank you very much. And what we'll do today is I'll introduce myself and Aniko. We'll talk about the role of data engineering and what that means, some of the challenges in fleet management, the types of fleet data, and this is ultimately part of a series of webinars that Aniko is running and events on transport data and analytics. And I'll share more about that during the session. But we are focused in particular towards the latter half of this webinar on fuel cost management, but some of those ESG concerns that were raised there will be covered in general. And when we want to go into more detail afterwards, we probably worthwhile doing some follow-up sessions. So, starting off there, I know the audience. I'll tell you about Aniko Fleet Management and this webinar series. So Aniko is a data engineering company. We have operated since 2004, delivering over 500 cloud and data projects, and they're in the areas of data and cloud consulting, so advising solutions where we're delivering, for example, fleet management reporting, and teams where we provide specialist data engineering skills to support in-house or multi-supplier delivery. And what we do is we help our customers and our partners build and operate data analytics platforms. We're a highly collaborative company, so our goal is to be the go-to collaboration partner to build and operate, so managing these platforms and managing the data pipelines is a key part. And with transport, as with most of the other industries, sustainability is a primary driver. But also there's an increasing, concern, particularly as generative AI and other models come in, about how we can be ethical in our use of data. And that's no different in transport. So why has Aniko got our transport focus? We work across sectors, but for example, we're working with TransLink on their bus, rail and data analytics. There's now 4 projects. We'll be working with the transport provider across about 400 KPIs. So they're everything from operational through to management and long-term HR and safety planning. I see that one of our attendees today is from Northern Ireland Water, and we delivered fleet reporting for them and are in a process of handover with that. We're working with a telematics company, Transpoco. There were maybe 17,000 vehicles we were tracking on a connected vehicle, so the telemetry and data, but we're looking at the business model, the unit economics of those. For a leading driverless vehicle manufacturer where they have sensor and camera data, we were optimizing the data pipelines. So how do you take all of that very rich, very large volume of data off, trial and operating vehicles and build it into a pipeline that can be used in downstream machine learning, image analysis. We've worked with partners, so system integrators and other suppliers, International Highways, Highways England, Network Rail, and going back now many years with a large supplier of content and dealership websites and other data in the automotive sector. We were building a uniform data platform and designing their how you would collect data and manage, a very complicated network of vehicles.
You're muted there, sorry. Colm, you're on mute just.
Sorry about that. Did you hear on this slide? Yeah.
Yeah, can hear you now. Yeah.
So within fleet management, we're looking across many functions in a business: the finance, maintenance, telematics, driver management, and speed and behavior. And they can be sensitive topics, and certainly there's a lot of personal PII information in there. Fuel management and health and safety, and the objectives in here: setting goals and strategies and priorities for the business. Most specifically, we hear of ESG and sustainability as key drivers, but ultimately there are rising fuel costs and rising cost of labor and other activities that drive strategies as kind of 1 and 2. So I guess rising costs and sustainability being the top strategic objectives we see. In strategies for replacing replacing with electric and hybrid vehicles, managing fleet services like registration, getting more predictive and predictable in maintenance, so understanding when vehicles need to be repaired, planning that in, and if you're a public service provider, knowing when your vehicles are in and out of service to meet peak vehicle requirements, improving safety and optimizing those costs. So this is part of a series of webinars and events. Back in June, some of you may have seen or joined our sustainable transport event, and we brought a number of speakers in, and the content from that is available. Here we're focusing on the fuel costs. In October, we'll look at optimizing transport. We'll be advertising that, so how you get insights, and very much focused on the discovery of data out of rail, road, air and maritime data. And in November, looking at an all-Ireland perspective. So I maybe didn't mention there, some of you probably know that Anico's a Northern Irish company, but we operate in Europe and North America, and in North and Southern Ireland there's a joined up or the great potential for joined up strategies. So when we look at the role of data engineering in fleet management, I mean, we consider data engineering the process of designing and building systems that enable you to collect and analyze raw data. And data engineering is empowering businesses to collate organizational intelligence, because very much the information is somewhere because you're using it in your operating processes, or your suppliers and your partners are using it. But it is often in very siloed systems, and data engineering enables us to bring that together. In those ecosystems, there's very often a shared data requirement. So what your organization consumes from your suppliers in terms of data are very often the key information you can share back, so that a supply chain can be optimized. And that helps overall optimize operations in both the physical asset costs, of vehicles, maintenance and fuel, but also in the operations. And cost and risk tend to be the two biggest reduction targets that we've seen. And Anico's a data engineering company, so we get asked to solve these problems. For those of you, it sounds like most who are on here are technical, but this is probably so basic for many of you. The platform principles: you have a lot of external data, vehicle assets, trip data, maintenance data, and you kind of need to develop a platform that will extract that information, clean it, refresh it, prepare it, and load it into a common data model from where you can report. And there are multiple ways you can do this and multiple platforms, but at its essence, this is what we do in data engineering. And during that process of taking base asset data, very often with either a tracking ID or a vehicle identification number that we have to VIN, that we might have to redact, we're integrating with sensor data, and that's coming off cameras, telemetry, and increasingly that's a huge volume of data. Third-party services that do checks and lookups. And ultimately, there's always an expert required to, add their knowledge, interpret this, before you're sharing out a complete vehicle record. The challenges we see in fleet management are many, but there are also opportunities. So there are rising fuel costs. The global fuel energy price index increased sixfold between summer 2020 and 2022. Global shipping costs increased also by 500% in that period. And this has been driven by an ongoing global energy supply shortage and geopolitical circumstances like the Russia-Ukraine war have exacerbated that fact. There's a driver shortage ultimately globally, and that may or may not be relevant depending on the type of business you are. There are targets to be achieved and regulations here. And they're kind of the objectives. So that's typically what a fleet management function is looking to understand and address. How do they optimize and deliver against these targets? By optimizing routes, optimizing fuel, and reducing emissions. But in order to do that, they have technical and operational challenges, like most of the information is coming from third-party suppliers, and very often there are different systems with slightly different nuances, so you're aggregating that data. There's a specialist knowledge within your organization. Many individuals are the experts and third-party experts, so they have to speak a common vernacular. When you're looking at data, that underpins all policy-based decision-making, and data literacy skills are often there in elements, but they need to increase. So it's not that they don't exist, but just the demands of reporting and data engineering in general requires these skills. And as we have more and more telemetry, more and more sensor data, there's increasing data volumes. And depending on your retention and archiving policy, that can significantly grow over time. At the most basic level, what we've seen is that organizations delivering fleet management, they're very clear on their strategic goals, but the tactical and practical steps of how they transform from individuals manually processing information through spreadsheets and extracts and taking that into a more automated way where more time spent analyzing the data rather than preparing it. And Enico steps in here. So we work across cloud platforms. We're a partner with AWS and Azure. We work across sectors. So, this here is in the transport, but into the manufacturing, the health and safety, government, there are aspects that come in. And the slide is busy, but we're basically saying that there's a data discovery at the bottom in the green. There's I guess, typically to be more sustainable, a move to the cloud and leveraging more cloud services is beneficial. So what workloads can be operated either by your business or by partners, we would lead into a cloud readiness assessment. From the user experience, it's very particular because you have lots of stakeholders, and so understanding your user and user research is important. And then the operating processes with, for example, AWS, we do a well-architected review, but they enable to look at the operational, the user experience, the platform, and the data perspective that need to join together to deliver against these goals. So we said in our agenda, we'd speak through types of fleet data. And I want to just very briefly touch on the suppliers and the formats. And when you look at fleet data suppliers and what you might need, you might be looking at servicing and repair data, various vehicle tracking platforms, most often an internal asset register that has a lot of vehicles by type and IDs, and where that's been correlated to other business functions. Then you have the departmental assignment and deployment, fuel supplier data, and a key point in here is that you will have very often the bunkered or bulk procured fuel, depending on your business, and what many call the forecourt fuel. So what you will buy if a vehicle's out on the road and a field manager, one of your staff, whatever it happens to be, is filling up on the road where they need to. That difference in cost of fuel supplier is a key area to consider. You have accident and incident reports. They may be coming from third parties or captured internally. You have departmental budgets and projections. And ultimately, this is a challenge that you need to understand, quite a complex data landscape. So in the formats, you have kind of legacy data. So very often when we're supporting on fleet analysis, there are a proliferation of spreadsheets, and they're very good for users, but when you want to automate this process, you need to pull that in. You may have historic information that can give you a past trend, but a challenge is that there is maybe not the same analysis. The data landscape's constantly changing. You'll have data from partners, sensor and telemetry, unstructured data, and when we're mining data coming off driverless vehicle analytics, it turns into petabytes of storage required. And so we're ingesting that through many sources, preparing it, cleansing it, scanning it, training models in the AI and machine learning, and very often we work with partners there. But the more simple prediction and reducing the complexity is where the key benefit comes from in analyzing. And once you have that foundational trust in the data, we need to measure it, monitor it, and report with key stakeholders. And across that data pipeline, there's a lot of different roles involved, and that is very often not, unless a very large organization, you have some of these individuals in your team. And a challenge that we in Anico address is these are the skills we have. So you need to have projects that are focused, that can bring these together, and patterns that can adapt to whatever kind of information you have. So moving on to the fuel costs element of it, and looking at the metrics, KPIs, and the fleet insights, and we'll spend a bit more time here on this. So overall, we probably see this requirement where there is an understanding of work patterns. So every organization is different. Almost certainly, if you're a large organization that merits a good fleet management and reporting, then you have divisional, departmental, and regional breakdowns, and the patterns of behavior between different kinds of workers, different kinds of vehicles. That best gives you a view of the productivity. There's asset utilization. Are there vehicles that are being overused? You need more of them. There's a peak vehicle requirement you're not meeting, or underused, they're parked. And one interesting case we've seen in vehicle tracking systems is that, if a vehicle has a lot of short journeys on a single day that are, well under a mile, it's usually been that it's been in the way, being moved around between parked areas in your business. As we have customers who are looking at broad regions, national operators, businesses that have field engineers, field managers that are going out, service engineers. And so there is you need to distribute your fleet across them and understand the needs, on that regional area. And your workforce who are driving these vehicles, you can risk safety by having them overworked. You certainly will have rotas and shift patterns on others if you're operating, beyond standard working pattern. And there are things that you need to manage and understand, and address. And the safety is paramount in here. So those insights very often come out. We start off, I guess most organizations are looking at the basic numbers, what type of number of vehicles they have by type and function over time. And some challenges when you're using third-party systems is IDs that identify those vehicles. Can be, which are really the telemetry and trackers, and not the registration number. They can be recycled. So you can often find that even the simple fact of how many vehicles you have at a point in time can reveal minor differences between different systems because a vehicle is registered in one and not the other. And some of those telemetry and sensors and IDs are reused, repurposed when one vehicle is replaced by another. You're looking at off-road and available numbers, so what spare capacity you have, the additions and removals timeline. Very often we see organizations who want to look at their least performing, most expensive vehicles, and as vehicles age over time, the repair costs and fuel consumption increases. So when you're looking at replacing vehicles, many businesses might have a calendar-based strategy to their budget. I've now got a budget for new vehicles, but the best way to look at the replacement will be from a cost perspective, and that has a link to age, but there is more detailed analysis. And those basic numbers, you need to be able to display those, have them available for your staff, management, and executive reporting to be able to quickly check and report against. Of fleet utilization, so the breakdown of journeys, mileage, time, how they're in use by type and function over time. So large organizations have many different vehicle types for different purposes, and those some might be seasonal. So a classic example, if you were to say a gritter, operates when there's a need to grit the roads. But there are specialist vehicles, heavy machinery that are used on occasion, and the type and function of the vehicle will determine. You need to look at that. And there are always exceptions. So the first time you aggregate all of this information and have a view onto it, you're going to find all kinds of anomalies, because the better you can see data, the more you can see exceptions in it. in fuel source, we kind of look at the key source data, when it's been filled. Did it come from the bunker, that bulk fuel that's cheaper or forecourt? And if it's petrol, diesel price per litre and where it's been billed to. And then we're calculating over time, and we typically look at kind of rolling averages are a way to look at that and look at the fuel spend. And in particular, that percentage of bunkered fuel is a key cost optimization view. So many organizations under their climate agenda, emissions control, and move to a more sustainable business are switching to electrical vehicle. And, we would analyze the journeys to see which vehicles are candidates. So is there an area that could be replaced, and then use the cost analysis of when is the right life cycle to replace a vehicle. And the economic life cycle of any vehicle by type and by age is a complicated asset or complicated analysis, because you have the capital value of the vehicle that depreciates over time. You have a service cost, so that you might have either internal or external suppliers for maintenance and repairs. And so, the servicing of that vehicle, if you're able to track it, you can see that it will increase. And you're looking at the fuel and repair and operational costs. So there is a life cycle to every vehicle. A way we would commonly approach this is to group vehicles, most commonly by that vehicle type, and then track these costs over age, so that then you can understand when's the right optimal time to replace a vehicle. In the fuel usage, I've mentioned it before, I will mention it again. I think it's something we've seen, that bulk fuel is cheaper than forecourt fuel. And when fuel prices are increasing, that's a key saving. So it may not always be possible. It is an influence onto driver behavior, because there is you're trying to encourage patterns of when you fill up and fill the tank before leaving the depot. The total fuel volume and idle time and fuel cost per hour, and there's a lot of analysis on idle time. Some organizations make a big point of trying to reduce it. There are now increasing efficiencies when a vehicle is idling. You hear cases where organizations say the engine's running because somebody in a field engineer needs to charge their ruggedized laptop or keep themselves warm while they're out on a job in winter. So, while it's been reported and analysed, historically made more of a difference, I think, than going forwards. And to get to the meat of this, this is our perspective on what would be the top fuel cost KPIs. Bulk or bunkered fuel versus forecourt fuel, that will make a significant direct difference. As you're informing by the fuel cost by fuel type, you're saying how much are you spending on petrol, diesel, and are you moving into electric or hydrogen powered vehicles. In the vehicle type, different organizations have different fleet makeup. So, you'll think of the type of vehicle, and within that function, within your business, those types of vehicles have different makes and models. And so understanding that at the top level is a great start. understanding if the fuel cost by vehicle age, and that has tied to that vehicle type. And then finally, while a great way for a large organization that has a departmental structure or a regional structure to better understand things is to create a comparative table so that one department, you're not competing one department against the other, but comparing. And so you're saying, well, our average across all 5 departments delivers this fuel cost per fuel type. Let's see what's one department's doing different to another. So I'll move now just to talk a little bit about some case studies before we go on to the Q&A. And I didn't want to spend too much on these, but the purpose is kind of to describe 3 different parts of fleet analysis. And the first one here will focus on a large-scale data volume in the driverless vehicle analytics. The second one will look at a complex organizational and regional structure. And then the third one will kind of consider a public sector or arm's length body typical reporting set and some of the challenges that a company like that might face. For this large electric vehicle manufacturer that Nico worked in partnership with IBM on, we were looking at the driverless vehicle analytics, and we explore these kinds of projects with both commercial and public service operators, as well as in this case the manufacturer, where there are lots of sensors. So there are, in this example, there were 800 sensor and video files per second coming off with 5 billion video frames being analyzed from the cameras that are detecting what is happening around the vehicle during this trial. And this trial had real vehicles with real registration or vehicle identification numbers that needed to be redacted, so removed out of the picture once they've been processed in the data pipeline, because that's part of the identification data. And you're building a very large, what we called a metadata lake. Now this metadata lake was billions of tags of data. And our purpose wasn't to analyze, our purpose was to enable analysis in here. And so the case study really at the simplest level was to say, show me every piece of information or show me the video files associated with a right turn at a T-junction, and show me an example where an individual pulled out. And in that analysis, we had to do a lot of processing. And so the analysis of large-scale telemetry data is costly because it requires a lot of compute. So the ability to deliver machine learning and leverage AI is great, but there are costs associated with that larger data volume. And there was a period for which the information, the raw data, needed to be kept. So by managing how we process, cleanse, redacted that data, and moved it between expensive storage for high performance analysis into cheap storage for long-term or tiered later archiving, delivered the total storage cost reduction of 70%. And so the timeline for those analysts to be able to analyze and that curated data prior to this might have taken 3 months to get all of the data prepared and cleansed. And by automating this process, it was down to a matter of days. So for that large scale data processing, which is probably larger than many here on the webinar need to consider, but the principles are exactly the same, and the opportunity to leverage cloud services in particular and third-party services is still the same, because that technology is now available to optimize a data pipeline to reduce the costs and accelerate the time to analysis. When I go then into quite an old project for Inico, you can almost tell by the slide where I pulled in here. We're working with a company around designing a platform for global dealer networks. And fundamentally, they had an inventory management systems and content management systems with data coming from manufacturers and dealerships and presenting that. And some of the names you might recognize in there. So these were how does that more sophisticated pipeline of checks and data sharing happen? And really, one of the key challenges was there was a lot of organizations that had organizational structures, and then we had regional breakdowns by dealer groups, and we had individual dealerships. And so this had to be managed at a national, at a dealer group and at a dealership level. So when you translate that into, let's say, a Northern Irish operating company, they will have divisional departments with depots. They will have functions that are delivering different kinds of services, and those breakdowns need to get applied across the information you're managing such that you get a common view. And then the last example I mentioned here, fleet management reporting. So the objective was to report against 600 to 700 vehicles with a goal of reducing costs and inform the move to electric vehicles. And so you had stakeholders inside the organization, like fleet management, finance, HR, individual drivers, heads of departments, operations, fuel suppliers, and asset managers, who all had a different ultimate requirement for the data that was being collected. So it's the same information, and the more you build a common data platform, the more that can be leveraged elsewhere. But that's a lot of different interests. And I guess, one of the the biggest benefit in a transforming organization when looking at fleet is they wanted to look where to replace the most costly vehicles first, while also reducing carbon emissions, so cost and sustainability. And one of our lessons learned, because this wasn't easy, is that there are third-party data is everywhere. So you're not just having a department or an organization. You have third-party fuel tracking and telemetry systems, and they all have a slightly different way of viewing. They might collect data at different cycles. They may have kind of permissions and recycle IDs in different ways, and may not necessarily support historical data tracking, where they can provide you a real-time snapshot, and when you're getting an export or a report, you then have to manage that. So that spending time understanding the third-party data and how it changes over time is essential. And that you needed to understand are these definitions at the very simplest level. What is a journey? So you might decide that anything that's less than a kilometer is not a journey, because it might just be moving the vehicle around. And so then when you're normalizing across many systems, you're now looking at journeys that are meaningful in the business terms. And data collection is rarely real time. In fact, it would almost be, bar bus operators and others who need to get near real-time data to their bus manufacturers, I should say, to the operators. You're getting information collected at source. It's been shared at a cycle through third-party systems. You're very often taking that into batch. And so you have to roll that up on a hourly, daily, weekly, annual basis. And your organization may have different reporting periods that may or may not be aligned with calendars or shifts or rotas. And so those, in this example here, we had to consider and understand what information was real time and how fresh it was.